Welcome to MAE 38 Homework 2 Problem 2 review. Okay, so the problem we have here is, in trying to move across a slippery, icy surface, a 175-pound person uses two ropes, rope A, B, and C. Knowing that the force exerted on the person by the icy surface is perpendicular to that surface, determine the tension in each rope. Okay, so with this problem here, there's a few things we should note before we start going. So the first thing we should note is this problem in equilibrium or not? So yes, this problem we can say is in equilibrium because the object is stationary with no acceleration. And because it is in equilibrium, we can note that all the sum of the forces equals 0. So this will be useful for us later when we're trying to set up our sum of forces equations. So the next thing we can think about is what forces are acting on the man. Or what forces are acting in this situation. So we can see that we have tension AB, tension AC, and then as the problem states, we have a force exerted on the person by the icy surface. So we can denote this as the normal force because this is the force that keeps the man from falling through the ice. And then lastly, we have the weight of the man himself. So those are the four forces we have. And then knowing about those four forces and where they act, we have to determine what point do we want to analyze. So we have three that are denoted here, right? So we have A, B, and C. But if we think about it, we should be choosing point A because all forces act at this point. So with that in mind, we can start developing our FBD of the particle. So the first thing you do when you're developing your FBD, you want to draw the coordinate system. This is just a good way to make sure that you understand what the positive and negative directions are, a way to keep notation consistent, and so on and so forth. So after you draw your coordinate system, we can draw all the forces acting in this situation. So in this case, we have tension AC, tension AB, the normal force, and then the force due to the weight of the person. So now that we have our free body diagram, and let me just note that this is all acting at point A, we can start developing our summation equations, right? So our sum of forces equations. So if we look at that, we want to figure out the sum of forces in each direction. However, there is something we still don't know, right? So we have our free body diagram, but we don't have everything split out into its components yet. So that is the next step that we'll do. So the first one we're going to look at is we'll look at AB. So to figure out tension AB, we know that this will equal the magnitude times the normalized direction vector, which is just the direction vector divided by its magnitude. So when we're doing this, what we will get, what we can look at first is we can say, okay, so what is the direction vector AB? So the direction vector AB will equal negative 30, right? Because this direction here is positive and we're moving in the negative direction, so we'll have negative 30i. We'll have right here. And then in the y direction, we are moving up, so we'll have positive 24 because that's 16 plus 8. And then lastly, we have our z direction. So our z direction is this 32 plus, sorry, just the 32. Yeah. So with that, we have 32k. And then we can use that equation or our direction vector to also find the magnitude. So once again, the magnitude AB is just equal to each. So you square each component, add them all together, and then take the square root, and that will get you the magnitude. So what we have here is negative 30 squared plus 24 squared plus 32 squared. And that equals 50. So now that you see the process, I'll let you guys try to do the other three. I would take a sec, pause it here, and then I will also write the rest of the equations so we can see them all written out. Okay, so now that we've had a little bit of time, here are all the vectors for all the forces, and then they are broken down into their components. So we have the normal force, the weight, and then both tension forces. So now that we have all of our forces, what we can do is we can use the knowledge that we got earlier that the sum of forces equals 0. So we know that the sum of each of these components must equal 0. So I'm just going to scroll down a little bit and then we will write this out. So sum of forces in the I direction must equal 0. So we have this negative 15 over 19 TAB minus 15 over 25 TAC, then plus 16 over 34N equals 0. And then we'll do same thing for the other two equations following a similar process. And these are all the numbers I'm getting are just from us finding the components of each of these force vectors. And then for our weight vector, we can just plug in the number we already know. So we have that 175. And then once again, yeah, same process for our last equation here. We'll just plug in the values that we know have a C component. Great. So now that we have this system, we have our three equations, and then all we have to do is solve these equations, because now we have this system of equation, we have these three equations, and we have our three unknowns, which are TAB, TAC, and then the normal force. So once you go through, you can set up those, plug them into each other to solve, and the result of solving that system of equations will get you TAB equals 30.8 pounds, and TAC equals 62.5 pounds.